So now let's talk about insertion sort. As we know before, selection sort is scanning to the right in order to find the smallest number, but insertion sort actually scanning to the left. Therefore, I'm gonna call the insertion sort the reverse version of our commander analogy. So our commander right here, as you can see, he's gonna look on the different direction than the one on the selection sort. And this is the algorithms of insertion sort. It's kind of like slightly different from the selection one. So at the beginning, similar to the selection sort, we're gonna have a starting number, but this time we're scanning to the left to find a number less than it. So the list above right here is actually a small example for us to see how this algorithm is gonna work. As you can see, the list is partially sorted, 1, 2, 4, 5, but number 3 is kind of like out of order. So we're gonna pick number 3 at our starting point, and we're gonna scan to the left to find the number that's less than number 3. So 5, are you less than 3? No. Are you less than 3, number 4? No. So 2, are you less than 3? And yes. So let's go back to the algorithms. If you found the number less than it, you're gonna insert your starting number to the position next to the number that's less than it. So you're gonna insert number 3 between number 2 and 4. And this makes sense because if you put number 3 right here, number 3 gonna be greater than 2 and less than 4 is in the valid range. But what happens if you put number 3 right here? It's not valid because 4 is greater than 3. And you cannot have something like this. It's invalid range. And after inserting, your list look correctly, and you're gonna update your starting number to the next one and repeat the algorithms until your list is sorted. So now let's have one real example in order to help us understand the algorithms of insertion sort. Our goal is to sort the following list into an increasing order. So at the beginning, we're gonna pick our starting number, which is number 8. And again, the yellow color right here represents the number that we currently scan, which is number 8. So we're gonna scan to the left because insertion sort actually scanning from the left. But for the level number 8, there's nothing. Therefore, we didn't do anything. So now we're gonna move to the second slot, which is number 7. And this time, there's something on the left. So we're gonna scan. So it's 8 less than 7. Seem to be no. So we're gonna skip number 8. But now, on the left side of number 8, there's nothing. There's no number. Therefore, it is safe for you to put number 7 before number 8. And let's assume there's number 9 right here. So it's not safe for you to put number 7 in between because 7 is less than 9. So this case right here is invalid. But this time, there's nothing on the left. Therefore, it's safe for you to put number 7 in here. And this also makes sense because 7 less than 8. So we're going to insert 7 before 8. And now, your list look like this. So now let's move to the third slot, which is number 6. And we're going to scan to the left. 8, are you less than 6? No. 7, are you less than 6? No. And now we ran out of number to compare. And again, there's nothing else here. And also 6 is less than 7. Therefore, it is safe for you to put number 6 or insert number 6 before number 7. So now your list is going to look like this. And now we're going to start to scan from the 4th position, which is number 5. So we're going to scan on the left. 8, are you less than 5? No. 7, are you less than 5? No. And 6, are you less than 5? No. After 6, there's nothing else to scan. So again, it's safe to put number 5 before number 6 because 5 is less than 6. And we continue to the 5th position, which is number 4. You scan left, you scan left, you scan left, you scan left. And until here you see 5 is still greater than 4 and nothing else left. So we're going to insert to the front. And you can see the rest is going to repeat the same. Scan left, 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 and then you can insert to the front. You start with the 7th position, you scan left, nothing is less than 2, nothing is less than 2, nothing is less than 2, 3 is still greater than 2, so it's still safe to insert to the front. So number 1, gonna repeat the same. And finally, number 1 gonna move to the front. So now, the sorting is complete and your list looks sorted in an increasing order from 1 to 8. So now, let's calculate the runtime of the insertion sort. And the table right here is actually the summary of what we just did. So when the machine performs the insertion sort, it actually have to scanning everything on the left, scanning everything on the left, scanning everything on the left in order to find the number that less than the starting number. So the gray box color represent the time that your machine have to scan from the left. And also at the beginning, your machine scan the starting number, so the yellow right here also represent another scan. Therefore, the runtime gonna depends on the total of time that your machine have to scan through the array, which is the summation of all the yellow and the gray box. So in the first row, you have one yellow box, so you can have 1. On the second row, you have one gray box and one yellow box, so the summation gonna be 2, which means 2 scan, because you scan the starting number, which is yellow first, and then you scan to the left, which is the gray box. In here, it's gonna be 3, because you have one starting number, 2 scanning on the left, 4, 1 starting number, and 3 scanning on the left, and so on until you have 8. And if you notice, I did not include the case when the list is sorted, like from 1 to 8, because during this state, it's already sorted, so the machine didn't have to scan through this list again. Therefore, the total time gonna be 0. So now, you add them up from 1 until 8. Your runtime gonna be 8 plus 7 plus 6 until 1. And it's gonna be 36. And again, similar to selection sort, number 8 right here represent for the length of the list. The list right here have the length of 8. Therefore, for n elements, your summation gonna be from n until 1. So the runtime gonna be n plus n minus 1 plus n minus 2 until 1. And if you simplify, it's gonna be n plus 1 times n over 2. And you do distribution, it's gonna be n squared plus n over 2. And as n goes to infinity, answer gonna be O n squared. Therefore, the insertion sort have the same runtime like the selection sort for the worst case scenario.